So E is your electric field, which is given by E naught 1 plus cos omega t, cos omega naught t. Omega and omega naught are given, and work function is 2eV. Find the maximum kinetic energy of the electron. We have a conducting shell, and you are sending the monochromatic wavelength of lambda. Work function is W. Find the final charge on the shell. If the frequency is tripled, what happens to the velocity and kinetic energy of the electron in photoelectric effect? 3 different questions. If wavelength is tripled, then what happens to the kinetic energy? Show how the scans on. Let's give it a try. So what is the catch with this? So there was a question like this in JEE once. They said y is equal to, they gave something like cos t, sine square, something like 2t or something. And then the question was, this thing consists of how many waves or how many SHMs? So basically you need to split this into multiple functions here. Look at this. So we can write this E naught into 1 plus cos omega t like this. E naught cos omega t and E naught cos omega t and omega naught t. So this can be written as cos a plus b and cos a minus b. That means this function which you are writing here is actually consisting of 3 different light waves. And each light wave has a frequency omega naught, omega plus omega naught, and omega minus omega naught. So out of all 3, who has the highest frequency? Omega plus omega naught. The one with the highest frequency will create highest kinetic energy. So you have to take only omega plus omega naught and ignore the remaining 2. Clear with this? So this electric field which you're talking about is that, remember, in EM waves, electric and magnetic fields oscillation, that's what we call as light. So this is that electric field. What about the second one, 9th one? So that's the main idea here, these kind of models. And then what about this guy? If you have a conducting shell of radius r and if you send a wavelength lambda, then what changes? If I had to explain you this, see, this is what is happening with that. So we have the shell here. As the light falls on this, the electrons will start escaping the shell. If the electrons start escaping the shell, this thing starts becoming positively charged. If this becomes positive charge, at some point, all these electrons which are going out, they will start turning back. This happens when you reach the stopping potential, isn't it? When the potential of the shell becomes equal to the stopping potential, the electrons will start coming back. So electrons will come back and the charge becomes constant when the potential of the shell becomes equal to V stopping potential. So what is V stopping potential? H into Hc by lambda is equal to work function plus E into V stopping potential. So you get V stopping potential is Hc by lambda minus work function by E. And what is the charge on the shell? Kq by R. Clear with that. From there you get the Q. What about these 2 equations? In a photoelectric effect, if you triple the frequency, what happens to the velocity and kinetic energy? That's a pretty good question. Try. I'll give you a minute. That's a standard model asked multiple times. Options would be like this. The speed becomes root 3 times. It'll be more than root 3 times. It'll be less than root 3 times. One of the most common mistake, people think if you double the frequency, kinetic energy doubles. That is wrong. But let's do those two, B and C. Take a minute. So if you triple the frequency, what happens? Look at this. So initially we have HF is equal to work function plus kinetic energy. Now you made it triple. Let's just call it K1. Now you made H into 3F. This is equal to work function plus K2. Take this HF and substitute here. This will be 3W plus 3K1 is W plus K2. So we get K2 is 3K1 plus 2W. You can clearly see the kinetic energy is greater than 3K1. And same way, if you look at the velocity here, V2 will be greater than root 3K1. So the kinetic energy will be more than 3 times and the kinetic velocity will be more than root 3 times. See, simple logic here. Let's say energy, work function, kinetic energy. Let's say energy is 100, work function is 50. What is the kinetic energy? 50. If you double the frequency or triple the frequency, double the frequency, energy becomes 200, but work function will still remain same. Kinetic energy is 150, it became 3 times. Can you see? It didn't double. The reason is the work function is not changing. So that is the thing. So HF plus this was the proof. What happens if the wavelength is tripled? Huh? Now here there is a possibility the photoelectric effect doesn't happen only. Remember, if you decrease the wavelength too much, you will have less than work function, then the electron won't come out only. So that is also a possibility you have to take care. But yeah, if you do it normally, you'll get this thing. It will be less than 1/3. Clear with this? So these are one important model of questions. This I hope you remember. Check it out. This period in the class notes. It's a good one. Let's see. Now be careful here. Huh? Most people, the moment you hear the word white light, violet to red, you think of Balmer series. That's the first thing that clicks in the mind. So be careful with that. So now he is asking, when a white light is passed through a hydrogen gas at room temperature, absorption lines will be observed in what? Now, in a hydrogen atom, where is the electron? In the first orbit. So if the electron wants to jump from first orbit to any other orbit, you need ultraviolet. That means you need Lyman series. Making sense? That means if you want to excite an electron from the first orbit to anywhere, you need to give Lyman series, but you are giving Balmer series. So that means you're giving less energy than required. So what will happen? Nothing will happen. So there'll be neither. Nothing will get absorbed, everything will just pass through. Now look at the second question. Now both are related. If the radiation of all wavelengths from ultraviolet to infrared is passed through the hydrogen, then ultraviolet will get absorbed. The remaining will pass through. If ultraviolet is getting absorbed, that means you can jump from one to any other orbit. Right? If you can jump from one to any other orbit, let's say you jump from 1 to 2 or 1 to 3, then while coming back, you can jump from 3 to 2 and 3 to 1. That means you can get both Balmer and Lyman series. So the important point is this. If an electron jumps from higher orbit to n is equal to 2, you will get Balmer series or visible light. But when you give visible light, there is no electron in n is equal to 2 to absorb. Are you getting it? If you had an electron in n is equal to 2, it would have absorbed the Balmer series. I hope that is clear. So be careful with that. So absorption lines will be only in Lyman series. So both are kind of related questions. If you send a visible light, you can excite an electron from 2 to 3, but your electron is in 1, so nothing happens. If you give everything from UV to infra, only UV will get absorbed. So you can jump from 1 to anywhere else. Clear? So D and A. So he's asking the absorption lines. So easy question, but people goof up because it's little theoretical. You have to think. Because when the moment you see white light, now you think Balmer series and you're like, oh, it must be the answer. This stuff you know. So anyway, just have a look at this. Find the binding energy per nucleon for 120-50 SN, mass of the proton, neutron. Just write the equation. I know its calculation is a messed up. Just write the equation and leave it, then I'll show you. So you're asking for binding energy. First, you need to find the mass defect, which is theoretical mass minus experimental mass. This thing is mostly, what do you call it? It's just mathematics, multiplication, division. So mass defect is theoretical minus experimental. Number of protons into mass of protons, number of neutrons into mass of neutrons. Subtract them, you'll get delta M, substitute 931 divided by 120. So calculation is a messed up thing. They do ask such questions. I think there was some year in advance, they asked a full paragraph on this. But concept is easy. There's nothing there. This is another type of questions. In a reactor, we have 2 kgs of uranium fuel is used in 30 days. The energy released per fission is 200 MeV. Given that one Avogadro number is this and 1 eV is this, the power output of the reactor is close to. What is power? Energy per time. Write the equation. Just get the equation. Let's see what will you write. First, you have to find the number of uranium nucleus. So 2 kgs, that is 2,000 grams by 235 will give you the number of molecules. And then number of nucleus into each nucleus will have one fission, which is 200 MeV. M is million electron volts, and the total time is 30 days in seconds. 30 into 86,400. If you divide this, you will get it in joule per second watts. You have to convert into megawatts. So this is another type of question they'll ask you in nuclear reactors. Do you guys remember in nuclear reactors, what are all the parts and what each part does? Can you just think about them for a minute? In a nuclear reactor, what are all the parts that you have, and what is the purpose of each part? Think. Take 30, 40 seconds, just tell it to yourself. So let me ask you like this thing. Think of like this. Now, in the nuclear reactor, what is the fuel that we use? Uranium. Now, in uranium, there are two isotopes. Which isotope we use? We don't use any isotope you want. We use the 235, right? These are called fuel rods. So you keep them in that. So when you keep this fuel rods, right, it is surrounded by the liquid and everything. This is called moderator, right? What does a moderator do? It slows down that neutron. So when a nucleus undergoes fission, it emits three neutrons, and these neutrons are traveling very fast. You cannot use them for a fission, so we have to slow them down, right? So if you want to slow them down, so there was a question like this thing also. So the moderator should be made of what kind of material in order to slow down these neutrons? And options would be something like this. The moderator must be made of low molecular weight, high molecular weight. Think of this. You want to slow them down, isn't it? So if two molecules have same mass, when they collide, what will happen? They'll exchange velocities. Means my neutron will slow down and the moderator will go away. If you use a heavy molecule, then what will happen? It is like hitting a wall. You'll bounce back with the same speed. So the moderator must be made of lower molecular weight, something similar molecular weight to the neutron. That is the reason we use heavy water, D2O. Heavy water or graphite or something, carbon, so something close by. We don't use heavy molecules. So moderator will slow you down. Generally, they use graphite or they use D2O, heavy water, that's called, right? And then after the fusion gets over, if you're getting too many neutrons, someone has to decrease the number of neutrons. This is done by control rods. Control rods will absorb the excess neutrons, and control rods are made of cadmium and boron. Now, all the heat that is being produced must be taken out of the reactor and must be used to produce steam. This is called a coolant. And for coolant, what is the best material to use? Liquid sodium. Because sodium is a metal and sodium can be in a liquid state. So liquid sodium is one of the best material to remove the heat to for this thing. There. So control rods absorb neutrons, moderator slows down, graphite and everything. Liquid sodium is for a good coolant, and we use 235 isotope. 238 does not work in the reaction. Let's get this thing. Lithium is given, helium is given, and mass is given. So when 20 grams of lithium is converted into helium by proton capture, so lithium absorbs a proton and gives out this helium. Find the energy liberated. So nuclear physics, all the questions are like this only. At a mains level, at least advanced level, if you remember, we did all that endo-ergic reactions, yeah, the nuclear collisions. Those things generally they won't touch here. And radioactivity is not there for mains. Advanced ke liye hai, so we will do that later on. But फिर भी few questions, basic half-life and all you must have done in chemistry. That much you should have an idea. Just write the equation and leave it. For all these things, the numbers are bad and not difficult to solve. First, write the equation. Let's see. First, this is the reaction there. So lithium plus one proton will give you two heliums. From there, we need to get the mass defect. So mass of lithium plus mass of this hydrogen must minus 2 times mass of helium. This will give you the mass defect. So delta M into 10 power 9, we need to get that is the number of molecules that we have. So 20 grams. And 10 power 9 is this thing. So there. So one mass of nucleon is equal to 1 giga electron volt. So that will be basically one AMU kind of thing. So from basically 1 giga electron volt by C square. So that's where I wrote directly 10 power 9 into mass defects. That's for one lithium. And 1 kilowatt hour, remember 1 kilowatt hour is not the unit of power, it's a unit of energy. So that is 3.6 into 10 power 6 joules. So divide them and you'll get everything you want. Clear with this? Total energy by kilowatt hours will give you the total number of the total energy released in kilowatt hours. So clear with this? So mass defect into C square will give you joules and divide by that thing. This is another one. In X-rays, we have only actually two formulas if you remember. One is that lambda minimum and second thing is your Moseley's law. Lambda minimum is equal to Hc by E voltage. That is the minimum wavelength that will come in an X-ray machine. And second thing is that graph and that Moseley's law. There are two questions here. Have a look at them. There. This is your Moseley's law. Root frequency is equal to A into Z minus B. And frequency is root C by lambda. So there. So they has given you two wavelengths, right? 4 by 1875 before, 1 by 675 R. So two different metals. So C by lambda 1 will be Z1 minus 1 and C by lambda 2 will be Z2 minus 1. Subtract them, you'll get the relation and finish it off. And this is your lambda minimum, which is Hc by EV. So voltage is your 10,000. So when you're operating 1 kV, the X-ray minimum is 6.22. When you operate 10 kV, it will be 1/10 of it, so 0.62. Got these two. So these are the two main formulas that you have in X-rays. In X-rays, as such, there's nothing more other than a graph and this thing. So in case you forgot, these are all the formulas of Moseley's law. Should definitely remember. Root frequency is A into Z minus B. For K alpha, A is root 3RC by 4 and B is equal to 1. And I hope you remember what does A and B tell you. A talks about the transition between orbits and B talks about the shielding effect. You should check out the notes in case you forgot. So A ka value depends on transition between orbits. And this is your lambda minimum there. And how do you actually get this formula? This is the derivation. Huh? because there have been questions like this. What happens if an electron jumps from 3 to 1 or 4 to 1? Then find the value of A. Look at the derivation. 1 by lambda is Rydberg constant into 1 by n1 square minus 1 by n2 square into z minus b whole square. Multiply C on both the sides. This becomes frequency. This becomes RC. Now put a root on both sides. You get root frequency is equal to this term into z minus b. There you can clearly see this thing looks like A into z minus b. So that's your value of A. So there was a question like this. Find the ratio of slope of K alpha and K beta X-ray. Slope will be A, right? So K alpha meaning X-ray is going from 2 to 1. K beta meaning X-ray is going 3 to 1. So A ka value will be different for K alpha and K beta. They can play around like that, messing up with the values of A. B ka value they have to give you. You cannot find out the value directly. This is the graph. So let me ask you this. This was a question. So V1 Z1, V2 Z2. This is the graph between intensity of X-rays versus lambda. These are all the chapters which we did. Like this is the last few chapters. Compare voltages V1, V2 and Z1, Z2. V1, V2 is the voltage of the Coolidge tube and Z1, Z2 is the atomic number of the target material. How do you compare this? See again, lambda minimum is Hc by Ev, so lambda minimum is proportional to 1 by V. So between these two, who has the minimum lambda? The lambda 2 ka wavelength is smaller than lambda 1. That means lambda 2 ka voltage must have been higher. So V2 is greater than V1. How do you compare the atomic number? You have to compare your K alpha or K beta. Look at this thing. The K alpha of red and K alpha of green. The red ka K alpha has more wavelength, meaning it is less energetic, isn't it? So think practically also. Forget about all the formula. If your K alpha means you're jumping from 2 to 1. So when you're jumping from 2 to 1 in both the atoms, the one with more energy must be having more atomic number, isn't it? Because the formula is 13.6 ev into z square by n square, blah, blah, blah. If n is same, whoever has more atomic number will have more energy. Whoever has more energy will have less wavelength. So whoever K alpha has lower wavelength, that guy must be more energetic, therefore more atomic number. But you want to get the formula, this is the thing. This is for characteristic X-rays. 1 by lambda is equal to R into n1 square n2 square z minus b. There you can clearly see 1 by lambda is proportional to z minus b whole square. Whoever has more atomic number will have more energy, therefore you have less wavelength. Clear with this. In this, if you remember, there were two more graphs. One is graph with pressure and one graph with temperature. Hope you guys remember. Should check it out. Those are not standard graphs. P is the pressure in the chamber and T is the temperature of the filament. If you increase the temperature of the filament, what will happen? More electrons will be emitted. If you have more electrons, you get more X-rays, so intensity will be higher. So the graph would look something like this. One graph is like this. And the higher temperature graph will be looking like this. The red one has more temperature than the blue one. Let's get this thing. We have a radioactive nuclide 11C6 decays by a beta plus emission. Beta plus is positron. Find the Q value of this process. So first thing you need to get the reaction there. So how does 11C6 become boron? So get the equation there. Look at this. So 11C6 becomes 11B5 plus 0E1. The charges have to be balanced. Masses have to be balanced. Yeah, and plus actually you also get an anti, and you also get a neutrino, 0, 0. That is something to conserve momentum. So that's a full equation actually. Whenever there's a beta plus emission, you get a neutrino. Whenever there's an electron emission, you get an anti-neutrino, which is massless and chargeless. And then, yeah, once you got that, your job's done. And this is the importance of this question. I told you this. Whenever they gave you the mass, what are they giving you exactly? They're giving mass of the atom plus electron. These are atomic masses. Which is mass of the nucleus plus electrons. But when you find the mass defect, you find only mass of the nucleus ka difference, isn't it? This error will always come when you have positron emission. So mass defect is mass of the carbon nucleus minus mass of the boron nucleus plus mass of the electron. What is mass of the carbon nucleus? Mass of the carbon atom minus 6 electrons. Mass of the boron nucleus, mass of the boron atom minus 5 electrons. When you subtract them, you'll end up with an extra 2 Me. Do you guys remember this? You will not have this problem if you have an electron emission. You will always have this problem when there's a positron emission. So be careful with this. That's the catch of this question. Because most people, what they do, they just subtract it normally. They'll subtract carbon, this thing. They will not get this 2 Me. You might think like, okay, 2 Me में क्या हो जाएगा? 2 Me is almost 1 MeV का difference. So if your answer was 3 MeV, 4 MeV, 5 MeV, you will get a difference in that much option there. One electron will give you an energy of around 0.55 million electron volts. So 2 of them is around 1.1. Clear with this? So be careful. Whenever there's a positron emission, we always get this 2 MeV. In beta plus emission, beta minus, you won't have this issue. But main thing is that when you do mass defect, you're subtracting mass of the nucleus, not the atoms. This is another good question if you remember. This was a PYQ also, old version. That's a graph between binding energy per nucleon and mass of the number of the nucleus. Which of the following process is possible? I'm sure you remember the answer, but think about how to do this. At least find for any one of them. It's easy to guess here, but let's see, you should know how to solve. Because exam they'll simply say like this. Imagine this reaction is actually possible. W becomes X plus Z. Find the Q value in that reaction. You're done. If they ask you that, you don't know how to do. Let's get this. So what is the Q value? Binding energy of products minus binding energy of reactants. Be careful here. What is given? This is binding energy per nucleon. So how to guess this? Think of like this. If you have higher binding energy, means you're more stable. Binding energy technically means it is negative energy, remember? Think of this way. What is the energy of an electron in the first orbit? Minus 13.6 eV. What is the binding energy of the electron in the first orbit? Plus 13.6 eV. So binding energy tells you how much energy is required to remove the electron from the orbit. Right? So higher the binding energy, more stable you are. So you can clearly see here, Y is the most stable element. So why will it break down, isn't it? Everyone wants to become Y, meaning the lower elements will try to combine, try to forming Y. The bigger elements will try to break, coming towards Y. So with that logic, if you see the option, first is a nonsense option. Y is more stable, it is becoming less unstable. W is looking very feasible, isn't it? W is becoming x plus z, possible, but still x is becoming y plus z, also possible. So B and D are maybe possible, we have to check. But C is definitely possible, isn't it? So how do we solve this though? There. So Q value is binding energy of products minus binding energy of reactants. Let me show you for the first one. So Y is becoming 2Z. So 2Z. So what is Z here? Look at the number here. So Z ka binding energy is 5 MeV per nucleon. And how many nucleons are there? 30. So 5 into 30, that is a total binding energy. And there are two of them. So into 2 minus binding energy of Y. For Y, the binding energy is 8.5. And how many are there? 60 of them. So 8.5 into 60. The difference is minus 210 MeV. Clear with this? You need to keep checking for all these things till you get positive. Whoever gets positive, that guy will release energy. Clear with this stuff? And then a few formulas here, hope you remember them. The radius of a nucleus is R naught into A power 1 by 3. A is the atomic number, R naught is 1.4 Fermi. N theta is the number of, this is a Rutherford alpha scattering experiment. N of theta is the number of alpha particles deviating by an angle theta, which is proportional to 1 by sine power 4 theta by 2. It also depends on 1 by b square and depends on z square. So these are the results you should remember. Theoretical questions, they do ask. Let's get these two. The force between the nucleus and the electron is given by F is equal to minus K R power 2.5. Assume Bohr's theory is valid, then radius of the nth orbit is proportional to R power x. Find x. You have seen this kind of questions in gravitation. If the gravitation between the planet and this thing is given by R power 3 by 2, find the new time period. Second thing, the potential energy of an electron is given by U is equal to U naught ln R by R naught. Assume Bohr's theory is valid. Find the radius and speed of nth orbit. So in Bohr's theory, this is one type of question where you mess up your basic general formula there. Yeah, let's give it a try. First one is 4. What about the second thing? Always R supposed to be R power x, n power x. So what is the catch in all these questions? In all these questions, the idea is always this only. When the electron is going in a circle, the force must be equal to k ze e by r square, k q1 q2 by r square. This is one equation. Since Bohr's theory is valid, mvr is equal to nh by 2 pi. Two equations, two unknowns. From there, you can figure out everything, velocity and everything. In the second question, they gave you potential energy. So how to find force? F is equal to minus du by dr. So from there, find the force. And then again, use the equation. Check. So this is your first equation. This is your second equation. Take that v, substitute there, you get r is equal to n power 4. That is how you handle these kind of questions. You just solve them, the two equations every time. In the next case, if potential energy is minus du by dr, you get force is minus u naught by r. You will observe, interestingly, velocity remains constant. Independent of the radius, for all orbits, the velocity is constant. And here r is proportional to n power 1. Clear with this. Now, another way of asking question is this. The electron is moving in a circle due to magnetic field B. You're getting it? There is an external magnetic field B, and then the electron is moving in a circle due to B. Assume Bohr's theory is valid, then r power n, r is proportional to n power x. So this electron is not going due to some electrostatic force or something. It is moving due to a magnetic field. Hypothetical question, but yeah, they can play like this. Can we use mv square? Why can't you use mv square by r? What is the doubt with mv square by r? Centrifugal force record. Why will not have a centrifugal force? Just because it's electron, it will stop obeying Newton's laws of motion and everything. Something like that. You are anti-circular motion person. How to do this thing? What is the magnetic force? QEB. Bas why change tha. Aur kuch nahi. Every time you somehow have to find the force, QEB is equal to mv square by r. mvr is equal to nh by 2 pi. Substitute, you get r is root n. Remember, na, radius of that nth orbit, mv by qb. Next one is important. Get these things. This we have done. An electron is moving in an nth orbit of hydrogen atom. The momentum is proportional to n power x, z power y. Current is proportional to n power x, z power y. Magnetic field n power x, z power 5. Magnetic moment n power x, z power y. Find x and y. And in case you forgot, these are the formulas you should remember. The radius is 0.53 angstroms, n square by z square. Velocity is z by n. Energy is z square by n square. These are some really good questions. You're combining Bohr's theory, modern physics with your mechanical questions. Get them, get them. Take 2-3 minutes, get them all. So what is momentum? Mass into velocity. Mass is anyway constant, so velocity is proportional to z by n. So it's n power minus 1 and y is plus 1. What is current? Current is charge by time. What is time? 2 pi r by v. So current is proportional to v by r. V is proportional to z by n and r is proportional to n square by z. So that is n power minus 3 z square. Are you getting how to calculate? Once you get current, what is magnetic field? The electron is going in a circle. It's like a current loop, mu naught I by 2r. So proportional to current, which is n power minus 3 z square, and r is again n square by z. So that would be n power minus 5 into z cube. That was a question they asked in the exam once, like, an electron is going in the first orbit and second orbit. Find the ratio of magnetic field it generates at the center. 1:32. And what is the magnetic moment? Magnetic moment is NIA. N is the number of turns, I is the current, and A is pi r square. But a better formula would be this. Magnetic moment mu bar is equal to Q by 2m into L bar. Yeah? Remember the formula? Magnetic moment and angular momentum. And angular momentum is nh by 2 pi. So this will be proportional to n power 1 directly. That would be a better formula there. There. Quite an important question. Should definitely know how to do this thing. This is a non-standard Bose model. I'm not going to show the derivation. You can check on the class notes. If the mass of the nucleus is considered similar to a binary star system, the formulas will change like this. The new energy will be En into mass of nucleus by Mn plus Me. This is the new radius. This is a new Rydberg constant. Mostly means they won't touch this, but they can still ask these kind of questions if you remember. This was there in the class notes also. If an electron jumps from n is equal to 2 to n is equal to 1 in a hydrogen atom and a deuterium atom, who will have more wavelength? Yeah, the question. Now, if you don't consider the mass of the nucleus, right, and if you do it normally, you will get the same answer. But the lambda actually gets affected by mass of the nucleus. So this is the formula there. So deuterium ka photon is more energetic than a hydrogen ka photon. Now, until unless you know these formulas, you can't solve this question. Derivation is a little lengthy and messed up. You can check it out, but do try to remember this. Advanced scale, it's pretty important. That will be a good advanced paragraph question. Mains me, I don't think they'll touch this, but we never know. Who knows? This year they might decide to slaughter all of you. What about this thing? We have a hydrogen atom going and colliding with another hydrogen atom at rest. Find the minimum kinetic energy of hydrogen if a photon has to be emitted. Atomic collisions. How do you handle these kind of questions? So if you remember the process, right? First, we always start with assume the collision is perfectly inelastic, because that is a process where you get maximum loss of energy. Now, when they collide, now remember this does not become heat, right? Molecules do not have a concept of heat. So this energy should go somewhere. The only way the energy can go somewhere is by absorbing this and use it to excite the electron from lower to higher orbits. This is what actually happens, in a gas. When you heat a gas, why do you think it starts emitting light? Think about this. The gas at higher temperature starts becoming more, when you switch on your gas stove, the flame is initially blue and then it becomes yellow and then you can't see the flame anymore. Because a heated gas, the molecules have more energy. So when they collide with each other, the energy lost is used to excite the electrons. And when the electrons de-excite, you get light. That's what we call as fire actually. What is fire? Fire is nothing but a highly heated gas, if you think about it. So when they collide with each other, as perfectly inelastic collision, speed becomes u by 2. Energy lost is mv square by 4. By symmetry, both will get mv square by 8 each. If your energy is less than 10.2, then electron will not be emitted. Collision will be perfectly elastic. So for a perfectly elastic collision, minimum you need is 10.2. So therefore, the kinetic energy is 40.8. Clear with this? Because they're going to share the energy, right? Clear with these kind of questions? These are atomic collisions. Hope you guys are remembering all this stuff. This is just formula there. This is also removed from the portion now. But just in case you know that for bits of this thing. If you have some metal like lead or something, and if you shine X-rays, they get absorbed. This is the formula. The intensity of X-rays is equal to I naught into e power minus mu x. Mu is the absorption coefficient and x is the distance traveled. So question should be something like this. If intensity becomes half after traveling 2 centimeters, at what distance intensity becomes I by 8? You can just put in the formula and finish it off. But this was removed in the mains portion. Bits mein hai abhi bhi, yeah? Bragg's law, remember? We did this in X-rays. Interference. So when you shine X-rays onto a lattice, the first light rays will bounce on the first one, then another X-ray will bounce on the second layer. This will be the extra path difference. That path difference must be equal to n lambda per maximum. So Bragg's law is useful to find the distance between two atoms. So in interference, remember there are 3 experiments. What are those? Twinkies tube. Bragg's law is one. दूसरा Fresnel biprism experiment. So we have Lloyd's mirror. We can keep saying, hey, names to are there. Compton effect. Remember this? Again, just a theoretical statement there, but there's something called Compton effect. It is based on particle nature of light. So what Compton effect says is when an X-ray hits a molecule, electron or something, it behaves like a particle and it collides. So we get one scattered wavelength photon and the electron will bounce off. So this is the formula for that. There's no proof for that. You just need to know the result. So you can see a lot of new terminologies. If you see in this last class chapters, right, this was the biggest issue we faced that time also. There were a lot of terms and new words coming up in every chapter. So in the next class भी वही होने वाला है. Semiconductors, bar magnets and all. Anyone remembers what is Curie's temperature? The temperature at which the person will get cured from a disease. नहीं. What is it? It is the temperature when the ferromagnetic becomes paramagnetic. ये सब याद करना पड़ेगा आपको. Let's get these two. Consider an electron confined by electrical forces to between two rigid walls separated by this. These questions are not tough, but that wording and the way it is kept, right, it feels like really weird. Like, what the hell is he talking about? So what is the catch here? Basically, this is confined between the rigid walls. Do you guys remember this concept? MBR is equal to NH by 2 pi. You can write this thing as 2 pi R is equal to NH by MV. And H by MV is nothing but N lambda. And then we say, this is the thing, we say actually the electron, which is going in the hydrogen atom, it actually forms a stationary wave. That is the reason the orbits are called stationary orbitals. If you go back to the story, right, it goes like this. Rutherford says, electron goes in a circle. Then the drawback of Rutherford model was this. According to classical theory of electromagnetism, an accelerating charged particle should emit photons. So a particle going in a circle will have centripetal acceleration. Therefore, it should continuously emit photons and eventually the atom should collapse. Then Bohr comes and says, boss, there are some specific orbits. If you go in these orbits, the electron will not release energy. And the reason why these orbits don't release energy is because they are stationary orbits. In a stationary orbit, the energy in one loop is constant. Can you see how the story is connected? So this 2 pi r is equal to n lambda. So n lambda is what? That's your maxima, constructive interference. So if your circumference becomes n lambda, this becomes a stationary wave. So any electron in this orbit will not lose energy and it is stable. Clear with the concept? So the first question is based on that concept. So if you have an electron confined by electrical forces between two orbits, 5 atomic diameters, so this is how it would look. So n is equal to 1 is first harmonic. The second harmonic is n is equal to 2. This is your second possibility, where n is your principal quantum number. Are you clear with this? Now he is asking for the lowest excited state. Lowest excited state is one orbit. So this is lambda by 2 must be equal to the 5 molecular diameters, which is the length L. So यहाँ से lambda आ गया 2L. But we know lambda is nothing but h by root over 2 into mass into kinetic energy, de Broglie wavelength. From here you got your kinetic energy. That's your answer. Clear what we did? Since you're asking the lowest stationary state, that means n is equal to 1. That is, it means it's forming one loop, fundamental frequency. So distance between the walls must be creating one loop, which is lambda by 2. From there you got lambda, but this lambda belongs to an electron, means this is de Broglie wavelength. Are you guys clear with this? And de Broglie wavelength is h by root 2 mke. There again, question is not tough, but you need to have that understanding it is forming a stationary wave. And what about 67? That is the formula I just gave you. N of theta is proportional to 1 by sine power 4 theta by 2. Now, if you don't remember that formula, you'll get slotted in the 67. You'll feel like, what the hell is this? And there, I just put the solutions here. Clear? Take a break. Come back by 9:40. We'll continue from here. Let's get this. Just get the equation. Star initial is 10 power 40 deuterons. It produces energy like this: 2H1, 2H1 plus 3H1 plus P. Let's get this, everyone. Chalo, chalo, focus, everyone. Stop laughing. Focus on the class. Chalo, others cams on. So here, the main thing you need to realize, right? If you actually combine the whole equation, you'll realize you're actually consuming 3 deuterons per reaction. And NME, you're getting helium plus 1 neutron plus 1 proton. And in this whole thing, you have to find the mass defect. Right? So you have to combine both the equations. So when you just add both of them, you'll see there are 3 deuterons, and this guy goes off, and you'll get these 3. Clear with this? So that means how many fissions are actually happening? This is a 10 power 40 by 3. These many fissions are happening. So in each reaction, you're consuming 3 times. So we have to do 10 power 40 by 3 into mass defect delta M into C square. Got this? That's your total energy. Once you got the total energy, and you're saying you're consuming 10 power 16 per joules. So time will be total energy by 10 power 16. That will give you the time. Clear with this? So this will be the working for it. You have to get the mass defect, multiply with 931, and then you do finish it off. Again, not a tough question, but just lengthy there. When a sample of solid lithium is placed in a flask of hydrogen gas, then the following reaction happened. Aditya will know the answer for this. Herr Aditya. What is the answer? When you mix up 2 gases and if they react, what actually happens? Chemical reactions are based on electron transitions, remember? The electrons are forming covalent bonds and all that bond. These are all chemical reactions. Here, lithium is converting into a helium atom. The element itself is changing. This cannot happen. This will happen when this lithium goes and collides, or you give a lot of energy. Here, you simply placed it in a flask. Are you getting the difference? If you just put it in a flask, the nuclear reactions won't happen just by putting it in a flask. I hope you're clear with that. Maximum what will happen, the lithium and hydrogen will react and might will create something like lithium hydride or something, it will create some compound. That's what it will do. It will not become helium. Hope you're getting this. These are chemical reactions. So again, theoretical questions, but it's lagging for some reason. That's the best thing. The given reaction is a nuclear reaction which can take place only if the proton comes into contact with the lithium nucleus. And for that to happen, you should fire with a really high kinetic energy. Clear with this? So that is one. Then now, if you remember your 1-year calipers and screw gauze, we did a pretty detailed, this is the last thing we did actually. So we'll not be doing all the theory, but again, you should check out the notes. So, but let's see a few problems though. Let's see how much you remember this. There, this is the reading of 1-year calipers. If this is the reading, what is the answer there? You guys remember I taught you a trick also, meaning without using any formula. Not a trick, basically, it is simple, basic math from the picture there. What was the idea there? Look at this thing here. Which point is overlapping? This point is overlapping. Now, here it is easy to see. It is, your this is your vernier. This is your main scale. So vernier is on the top. This is 3. So this is 2.9, 2.8, and this is 2.7. It is 2.7, and this guy is matching. So it's 2.74. Clear? You can see and tell that way. But let me show you that method. So this 3 is matching here. So the idea is this. Whatever object you place, that must be somewhere here. Isn't it? You keep the object there and you move the 1-year calipers. So this distance is 4 vernier scale divisions, which is 0.9, 4 into 0.9 mm. That would be 0.36 millimeters, right? And so this length be L. And this point which is overlapping is 3.1 centimeter. So can I argue like this? So L plus 0.36 millimeters must be 3.1 centimeters. Isn't it? This length plus this length must be this total length, na? Is that idea clear, everyone? That's it. That's the whole concept there. If I take the length from here, this starting point, this is 3.1 centimeter because this is starting from 0, and that must be that. So this would be L is equal to 3.10 minus 0.036. How much is that? That looks like that is 2.74. Clear this? Now, this is pretty useful, even if you have non-standard 1-year calipers. Let's see this one. The smallest division on the main scale of a vernier calipers is 0.1 centimeter. The divisions of the vernier scale correspond to 9 centimeters. The figure on the left shows the reading with no gap. So when there is nothing inside, this is what it is showing. So basically there is some error. When you kept the solid sphere, this is what it's showing. What is the diameter? The first thing, this is a zero error, right? Where is a zero error? See, this division is matching here. So that is 1, 2, 3, 4, 5, 6. So, and what error is this? Remember, vernier is behind, that is 0. This is a positive error. And the correction is -6 vernier scale divisions. Meaning even when there is no object, the instrument is showing you 6 times the vernier scale divisions. So it means it is showing more. Now it is matching here, right? So this is clearly 3.11. So we can clearly see this is 3.1. You can go back to the regular method, what I told you now, or you can do the normal way also. So this is 3.1 centimeter plus 1 vernier scale division, but there is a correction of -6 vernier scale divisions. That must be 3 point. That's 3.10 minus 0.0. How much is 1 vernier scale division? 0.1 centimeter. The main scale of a vernier calipers is 0.1 mm. That's 1 mm basically. Wait, I'm doing a mistake here. This is least count. This is the least count. And least count will be 0.01 centimeter. Yeah, so this is 3.10 centimeter minus 0.05 centimeter. I'm getting 3.05 centimeter. Huh. Mm-hmm. What did I mess up? This is right only, na? It's 3.1 plus something. I think there might be an error or I messed up somewhere. You will get 3.15. It was 3.2 minus 0.05. Am I messing up somewhere? This should have been 3.05, right? Or you can do the regular way also. That also works. What was the correction here? So basically this would be X and that is matching with 6 and this is 5. That's 0.6 centimeters minus 6 LC. That's a negative error. Oh, right. Shit. There's a negative error. Vernier ka 0 is behind actually. This is a negative error. Correction is positive. Positive how much? This is the 6th division, na? But remember, negative errors we have to be careful. It is not 6, but it is plus 4. 10 minus 6 होता है correction इसमें. So this is plus 0.04. Then this is 3.11. That's right, only I messed up. 0.04 centimeter. Yeah. So be careful with that. So main scale ka zero is this. If your vernier ka zero is behind it, it is a negative error. If it is before it, it is a positive error. Luckily, that option is not the 3.05. I didn't see that. I think previous one year was top, na? Now it is down. Be careful. I got confused. What about this guy? So check out the notes. We did more on this thing. Like we were going to do it again in advanced May. Mains May, I don't think they'll go beyond this thing. Advanced May, they'll ask you all that non-standard vernier calipers. Yeah. So we have a screw gauge there. We have to find that. Screw gauge is more easier than vernier calipers. So what do we here? You can clearly see 5, 6, 6, 7, 8. And here it is 35, 36. That looks like 37, I'm guessing. So that's 0.837 centimeters. Easy. That is one. Now I'll do one thing. I'll send you a small sheet. Download that. We are going to do questions from that directly. I'm posting it in Zoom. I'll post it on the groups also. I wanted to keep it like a test, but then I said, okay. It will be too much actually. It's all just that is one. This is one sheet full of errors and everything, experiments. So we'll do a few of them. Remaining you will write as a assignment for yourself. Post it in the group. Check it out. So in this, let's not do everything. Let's do question 1, 61. You can start doing. If you're finished with this, then do the remaining also. Do 61, do 62. Let's do 63, 65, 66. 76, 79, 80, 81, 84, 88, 90. Bus, let's finish all these things. 12 questions. Remaining will be your homework. You can try. So start doing them. I'll show you the solutions for one after another. And if you're done with all these things, then you can continue doing the remaining. You can just note down the question number somewhere. Keep doing, keep doing. There, that was the first one. So you can clearly see the number of circular divisions shown in the screw gauge is 50. It moves 0.5 mm for one complete revolution. So basically from there you can find the least count. Least count is nothing but pitch by the number of divisions. And main scale is half mm max. So the diameter of the ball is. So look at the initial picture here. Even though when there is no object, the zero is visible. So zero is visible means it is a positive error. In negative error, zero is not visible. And it is showing 5. Means even though when there is nothing, you're showing 5 divisions more. So the correction is minus 5 least counts. Now you're showing 225. So this is 2 main scale divisions plus 25 least counts minus 5 least counts. So that is 2 main scale divisions plus 20 least counts. One main scale division is half mm. That's your 1 MSD. That will be 1 mm. And the least count is 0.5 mm by 50 divisions. This is your LC. That is one complete revolution. That is 0.01 mm. So there, that will be 0.01 into 20, 1.20 mm. Clear with the calculations? Got it, na? So you have to find the least count from here. So 0.5 mm is your pitch. 50 is the number of head scale divisions. Once you got the least count, you can finish it off. Keep going. Keep doing the rest. The next thing, tuning focus of frequency 340 plus or minus 1% is the error. Resonance column tube. I'll send you a PDF also for all these experiments. I think I sent you before, but I'll forward it again. So there is some file of 40 or 50 pages, containing all these experiments. You can just go through that. But again, advanced skill is more important than means. You can just have a look at this too. This is how you find the error. So this is the formula for speed. Do you guys remember how to get that? For the first harmonic, what is the thing? We know for the first harmonic, L2 minus L1, the difference between two readings is always equal to lambda by 2. This much you know. In a resonance column tube experiment, the difference between two consecutive readings is one wavelength, one loop, lambda by 2. The lambda will be 2 into L2 minus L1. Therefore, the speed of sound will be f into lambda, which is 2f into L2 minus L1. Got this? This is the relation between the speed of sound and the frequency and the lengths. Now you want to find the error in this, so put log on both sides. That will be log z, that will be log f plus log L2 minus L1. And then you differentiate dc by c is equal to df by f plus dL2 minus L1 by L2 minus L1. Clear with this? Now, but you have to be careful here. So what is this L2 minus L1 exactly? So here, when you're doing dL2 minus L1, so L2 is how much? It is given something, L plus or minus delta L1, L2, and L2. So basically, errors will add up here. Huh? So this term here will become delta L1 plus delta L2. Yeah, errors don't subtract, errors always adds up. And then L1 plus this L2 minus L1, you can finish it off. This is L2 minus L1. So here, this is the catch. Huh? The errors always adds up. You should not do delta L1 minus delta L2. L2 minus L1 will be 74 minus 24 plus or minus the error will be 0.1 plus 0.1. That is 50 plus or minus 0.2. That is better. Clear with that? Whether you subtract or add, errors are always additive. You should definitely solve this entire sheet. Huh? Save it and keep it with you. It's a pretty good one. Keep going. Get the 63. Question 63, 65, 66. You can just keep going in order. Tension मत लो. पूरा तो करना ही है. So hope you guys remember for the time period of a pendulum ka formula. T is equal to 2 pi root over L by G. Then we do dt by dt is equal to half dl by dl plus half dg by g. There. This is the formula. Substitute and finish it off. Pretty standard thing. Now, one thing, now, if you notice here, they're not giving you the errors. So how do you get what is the error? Look at the number of decimals. When you say 2.00 means you're accurate up to the second decimal. So this is actually 2.00 plus or minus 0.01 second. Is that clear, everyone? If they don't mention what is the error, you take the decimals here. So this length is supposed to be written as 50.0 plus or minus 0.1 centimeter. Clear? The number of decimals is the error. So then you're done. Put it there and you'll get it. 65. Y is equal to L square minus L cube by Z. Then find the error in Y. Now, how do you do this thing? Now, this does not look like any standard formula, isn't it? See, in errors, what are the standard formulas? A plus or minus B, A into B, A by B, or the power formula. Uh, A is equal to P power X, Q power Y, R power Z. Then error dA by A is equal to X times dP by P plus Y times dQ by Q plus Z times dAR by R. Remember this? That was the power rule. This thing does not look like any standard thing. So when you have nothing like this, differentiate. Differentiate on both sides. dy will be equal to 2L dl minus this thing we have to do the 3L square dl by z plus minus 1 by z square L cube dz. You literally have to differentiate the whole thing and then you substitute everything, right? You know, L dl, you know, Z dz, put it there, you'll get the answer. There. Here, there is a minus sign, printing error. So if they give you something weird function, which is not a standard, just differentiate it and put the terms, you'll get the answer. Clear with this? 66. Two masses M and MB are weighed using same weighing machine. So this is the thing that if you use same weighing machine, you'll have same error. So delta M is same. So then what is the errors? Delta M by MA and delta M by MB. So whoever has more mass will have less error. The MB is more, so it was clear with this. So the error depends on the machine that you're using. Clear with this? So that's it. All the error questions are like this only. Straightforward. You can check it out. But let's do one thing like this. Let's do 76. This is based on units and dimensions. Let's finish off. This will be the last one. The rest of the questions you can handle it. It's all the same thing. Error, error, error. Mains level, I don't think they'll go beyond this. Advanced may still we can do more deadly ones. We'll mix up errors and 1 year calipers together. In the formula, x is equal to 3y z square. X and z have dimensions of capacitance and magnetic induction. Magnetic induction is B bar, magnetic field. So it's like the full name of magnetic field is magnetic field induction. That's your full name. What are the dimensions of y in MKSQ system? That's like what meter kg second charge. Yeah. Straightforward. कुछ नहीं है. You should just substitute the formulas and finish it up. That's it. Make sure to complete the sheet. And the form, the experiment ka thing also I'll send you. You can just go through that. Just skip the pages and scan through the pages. You should know the terminologies. You should know what experiment means what. There, it's direct substitution there. You should know how to find the dimensions of capacitance. Which formula will you use? Q square by 2C is energy. For magnetic field, which formula will you use? force is equal to QEB. Because he's asking in terms of charge, let's bring charge everywhere. हो गया ना, substitute will get the answer. And let's do one more. There's something I want to show you actually. Let's do this one and then I'll show you something else. 90th one. Let's do question 90 and I'll show you a variation of this. So there is something there. In a UV method, that is to find the focal length of a lens or a mirror. The object distance is found to be 10.0, image distance is found to be 10.0. Find the maximum perceptible error in F. This is another important model in errors. The question 90, the last one. Let's do that and then I'll show you a variation of that. Again, if you remember, this is not any standard formula there. How to do this thing? Now, if you remember, we know 1 by focal length is 1 by V plus 1 by U. Again, doesn't look like any standard formula. So keep it simple. It's not a standard formula, differentiate. dF by F square minus N will go off on both the sides. dV by V square plus du by U square. There you'll get the dF from there. So 10.0 meaning the error is 10.0 plus or minus 0.1. Substitute there, you'll get the answer, done. Clear with this? That is how you do. Now, let me show you a variation of this, which was asked actually like 2024 or 2023. They said there is a lens. This is at 60 centimeter, 60.0 centimeter, comma 0. Object is here. This is at 20.0 centimeter, comma 0. Image formed somewhere here, which was 120.0 centimeter, comma 0. Find the error in focal length. So in a lens experiment, on a meta bridge or on a scale, the object image and the lens positions are given. Find the error in focal length. So the error is this. इसमें कुछ नहीं है. What is U here? Most people will write U is equal to 60 minus 20, 40 plus or minus 0.1. That's where everyone goofed up. You can ask yourself, what is U? U is the distance between the object and the lens, isn't it? So U is actually 60.0 plus or minus 0.1 minus 20.0 plus or minus 0.1. This is 40.0 plus or minus 0.2 centimeter. The error actually doubles up. समझ में आया? Because U is what is the difference in the previous question? In the previous thing, he gave you the length is found to be 10.0 directly. So this is u only. But here you are calculating u from two measurements. Are you getting the catch? Same way, v ka value will be 120 minus 60. That is 60.0 plus or minus 0.2 centimeter. Now we apply the same formula. df by f square is equal to du by u square. Everything is same except this thing. So this du is 0.2 and dv is 0.2. Substitute and get the answer. I think 2024 mains or 2023 mains. So there were two answers. One was 2 centimeter and one is 1 centimeter. There's a double answer there. Most people didn't get it. So be careful with this thing. This is a trap. You're measuring u from two measurements. So error adds up. If I give you u ka value directly, that's a different story. Clear? There. So that is a bit of it. So okay, with that we'll wrap up for the day. On Friday when we catch up, we'll continue. Right? Friday mostly we'll see, like, we might have, not sure actually, all that semiconductors communication now we will see. So try to revise and come. You guys must have forgotten everything. At least go through all the notes that we did recently. Okay, I'll catch up again on Friday. We'll continue from here. So any doubts, anything else, please stay back and ask, or else you are free to leave.